Well, hi everybody. My name is Andy Cotgreave. I'm technical evangelist at Tableau, and well, it's fantastic to be here today. I love the branding of this conference. I think this Soviet iconography is some of the best branding I've ever seen at a big data conference, so well done to the organizers. I wanted to talk to you today about the beautiful science of data visualization. Those of you who were in the previous talk with Matt saw him talking about the fourth industrial revolution, and it's going to be powered by data. And if we take our data and we can't communicate it effectively to our stakeholders to drive insight and drive change, then there's no point in having that data. That's the whole point. And the great news is that the science of data visualization is there to help us communicate things effectively, bringing together science and creativity. So I'm going to talk about that for the next 30 minutes, and I'm going to start with one of my favorite examples of some of the sort of just subtle touches of scientifically known aspects of data visualization to create a hugely impactful message. So this chart came from the South China Morning Post 5 years ago, and it shows deaths in Iraq month by month from 2003 to 2011. What visual metaphor was Simon Scar, the designer, trying to make you see? Correct, blood, a smear of blood. Simon chose three aspects of data visualization or aspects of communication to put that message across. He pointed the bars downwards, which is unconventional but fine. He colored them red to bring across the color of blood, and he chose the title, Iraq's Bloody Toll. The title itself gets in your head before you've even looked at the chart, and just those three words tell you how you should read the chart. It's a really powerful message. Also, with this data, it just so happens that the data has this V shape, which looks like a smear of blood. Any other shape of the data, and he couldn't have made this message. And this is how we can use the science behind cognitive science and neuroscience to communicate information. So if he did those three things, we could change them and see how that maybe transforms the message. So the first thing we could do is turn those bars back upwards, which is more normal. Second thing we can do is change the color to remove that evocation of blood. And now, there's a totally different story in this data set that becomes apparent. In 2003, during the Gulf War, there was lots of deaths month by month. That was a tragedy. Things dropped. And then in 2006, 2007, sectarian violence was again ripping Iraq apart. But after that, monthly deaths dropped. In fact, they dropped to the lowest monthly death rate that's there on the chart at all. Now, that's actually a positive story. Obviously, it would be great if it was zero, but it's a positive story. So we could then change the title, one of the most important sections of any visualization, to Deaths on the Decline. So we haven't changed the chart, we haven't changed the data, we've just changed some of the aspects we can do to visualize data and communicate messages to create a completely different story. And the great news is that there's now decades of research into understanding how design works and how our brain interprets data to be able to communicate messages like that, and also explore data so that we can get the insights we need. At Tableau, we've got one of the best R&D departments in the world looking at the science of data visualization. Here are some of these people, some of the fantastic colleagues I have. In the top left is John McKinley, who leads the team. He was working in this field in 1976, when I was 4, and certainly not into data visualization then. But he's an amazing, inspiring guy who really pioneered the field and now helps us put science into the products we build, such as Tableau Desktop and Server. And it also enables me to learn from them and share some of this stuff with you today. So the visual system is amazing. The light goes into the eye, the visual cortex interprets it and filters it, and sends to the brain the information that it thinks you need to know at any given basis. That's a system that has evolved over millions of years, and that system that's evolved enables us to see data. That probably wasn't the goal, but it's certainly a great outcome. And we can prove it. I'm going to do like a whole neuroscience course in 1 minute now. With this, how many 9s are on the screen? All right. You all know you could answer that question, but you all know it would take a while to answer it because you've got to look at the data one by one. You've got to look at every digit. So if I want to make one change, now it's easier, right? There are 11. You don't actually have to count them. There are 11. But what I did there was use what's called a pre-attentive attribute. What happens when you change color in something we're looking at is that the differences in color we actually see before we consciously ask a question of the scene in front of us. This was very good when we were escaping lions and looking for non-poisonous berries, but it's also really good now we're trying to see charts. So thank you to our forebears for that advantage. And here are 10 of many pre-attentive features that we see. So even before you started looking at these 10 things, you saw the longer bar. You saw the bigger circle. You saw the fatter bar. Right? These are pre-attentive features, and this is the amazing core part of the science of data visualization, is that these are the building blocks from which we can build charts that are effective. Because if it's not an effective way of looking things, then it's not. Then that's no good. How to draw a staircase? Well, this is one of the key aspects of visualization. Escher drew this brilliant staircase, right? And he was rightly celebrated for drawing a staircase which confuses us. This was like the 3D exploded pie chart of staircases. The science of visualization tells us that we can create beautiful, effective visualizations, and we kind of have to make the staircases, we have to make them look like this. Our job as data analysts and data communicators is to create clarity, not confusion. But we can still make staircases look kind of beautiful, if not confusing. And when we see data, we see things that even statistics can't show for us. So here are 4 sets of numbers. This is a set of numbers called Anscombe's Quartet. It was invented by a scientist in the British statistician in the 70s who was beginning to rail against the computerization of analytics. Computerization. Now, visually, we can't see much there. It's very hard to interpret anything for ourselves. If you run this through a stats package, they all have the same mean. They all have the same variance. They all have the same slope line. They're statistically extremely similar. But when we visualize them and when we explore this data to try and get the insight, this is what they look like. Group A, Group B, Group C, and Group D. Now, machine learning, AI, all those algorithms, they're amazing, but don't take away the power of your own eyes to see things that machines are still going to be extremely slow at seeing. If you do this kind of pass and iterate through your data, you're going to get these insights that Anscombe was trying to demonstrate to you. And again, you can see I'm just using position on an X and Y scatter plot to visualize data. It's incredibly powerful. Position being one of the pre-attentive features. So if we have pre-attentive features, we then need to map those to the kinds of data that we have swimming about our data lakes, our data swamps, our data archipelagos, whatever you want to call them this year, I don't know. Data oxbow lakes, maybe. And in our database is 3 types of data: categorical, ordinal, and quantitative. How do we map those to these pre-attentive features? I'm going to take inspiration for this from Star Trek. Are there any Trekkies in the crowd? I think it's a bit of a generation thing. Maybe should be going for Game of Thrones or something. I don't know. But anyway, I am how old I am, so Next Generation was my thing. So I'm going to take some data about Star Trek and show those 3 types of data and map them using the pre-attentive features. The first type of data is nominal. These are things, objects, like shoes, screen. They're just objects, or episode, the name of an episode. And here's all 178 episodes of Star Trek just encoded using position. Not very useful, but that's nominal data. We can encode it using position. The next type is ordinal data. These 2 are things, such as seasons 1 to 7, 7 seasons of the Next Generation. And in this case, I've encoded that ordinal data, which is discrete but comes in an order, using color and position. Now you can see which episode came from which season. But the third type of data, the kind of data, hang on. Now I've done another positional encoding. So each season This is season 1, season 2, season 7. But then we want to actually look at quantitative data. We want to look at things we can aggregate, and this is why we analyze data. We're always looking for the aggregations, the sums, and the progress. And for this, I took data from imdb.com, looking at the episode rankings for every episode of Star Trek. And again, we can use position again to encode quantitative data. So what I do there is on the y-axis, the higher up, the better the episode was, the higher the ranking, and the lower down, the worse it was. Just to recap there, we talked about preattentive features. This is why, when you look at charts, you can see stuff if the chart is designed properly. And then with the different types of data, you've got to think about how, or tools like Tableau do the work for you. They think, well, what is the best way to encode each of these types of data you have on your canvas? You can actually see that position turns out to be the most efficient way to interpret data of all types. But you can also use color, angle, size, shape, etc. And then you get insight. Finally, you get insight, and it's like, what the heck was this? What was this awful episode? Probably only the Star Trek super nerds know that the worst ever episode of Star Trek was The Shades of Grey. It was written with no budget, and they just, it was the season finale of season 2, and it was just an awful episode. Don't go and watch it, because it is terrible. But there you go. We just use science to discover the worst episode of Star Trek across all franchises. So there you go. That's non-business insight, but still pretty cool for a Thursday afternoon, I think. I hope you agree. Right. So there you go. We've done the science. That's it. You can go and do a 3-year degree on that, but we've just done it in 10 minutes. And so we've looked at how the brain works. We've looked at preattentive features. And I very quickly talked about how you encode that stuff onto charts. That's great. And that gives you data visualization. But the real point of what I want to talk about today is that data visualization gives you charts. And I think a lot of people in this field think that is the start and the end of it. And it's not. If you build dashboards for your organization, they are just the start. Dashboards answer anticipated questions. And that's chart building tools. There's plenty of them available. The real value, as we go into the 4th industrial revolution, powered by data, is taking data visualization and bringing into it the power of visual analytics. And this is completely different. This is about looking for insight in your data that you may not have even anticipated would be there. Doing ad hoc explorations to shift perspectives and chase hunches to let the data expose the things you need to discover, rather than you going down a straight line. And here's a very scientific diagram that I use to illustrate this. This is actually from the design world. It's called the Squiggle of Design by a guy called Damien Newman. But it represents to me the power of visual analytics over data visualization. When you're exploring data, you shouldn't be constrained by thinking, I've got data, I'll do a timeline of this data because it's got time in it. You should be trying to find the best articulation of your data. So when you connect data, you don't really know where you're going to go. And this is even if you're building a dashboard, you don't know how that dashboard should look at the end. If you're doing ad hoc exploration, you don't know where you're going to go. So you go on like a squiggly journey through your data, maybe going off on tangents because some other questions become more interesting and, in fact, more enlightening. We've got hundreds of examples of Tableau customers who've gone down one path and ended up discovering money savings in a completely different area. And as you do that exploration, you begin to kind of hone in on an output, which is the best articulation of the data for that moment. And this is really powerful to me, this diagram, because this side of it, I should be over here. This side of it, this is data visualization. This is dashboard building tools that say, okay, you want a dashboard of sales over time? Well, there you go. And that's actually really disappointing in 2016, because if all you have is this, how do you know you've actually seen the best insight out of your data? It's these two aspects of exploration which are vital to data visualization and the science of the science behind it. I want to show you an example of the power of iteration through a project that I've been running with a friend, Andy Kriebel, this year called Makeover Monday. Each week, we share a chart and the underlying data on Twitter. And we say to people on Twitter, hey, do a cover version of this chart. Remake this chart maybe in a better way, improve its story. And there's two aspects of this project which have blown me away. The first one of which is the amount of participation we've had. In fact, this chart's 2 weeks old, but we've got over 2,500 submissions, of which I think about 2,480 were built in Tableau. That's about 50 a week. It's 56 a week, and it's from over 400 people now. And just imagine that on your business data. Imagine if people could have that creative freedom to look in your business data, maybe just half an hour a week. They could probably find all sorts of insights. And again, you can come to the Tableau stand. We can tell you some of those stories afterwards. But the second aspect of Makeover Monday is the way it can illustrate this power of iteration. So I'm going to play a video. And this is essentially one screenshot. Well, this is the output of 1 hour's exploration of data in Tableau that I did in 1 week of Makeover Monday. What I did is I got Tableau to create a screenshot every time I iterated with the data. So we're going to fly, oops, oh, yeah, that kind of ruined the surprise, didn't it? Let's see if I can play it. All right, so what you're going to see is every iteration of my data that I did over 1 hour of exploration. So the point of showing this video is I didn't really know where I was going with this data. I didn't really know what the story in the data was. I didn't know how I was going to display it in the end. And as you look at the video, you can see I kind of I'm clearly focused on that downward-facing bar chart. I've got data that's similar to the Iraq's toll. But what you can see is I go from the bar chart, and then I go back and try different views. Maybe I try a pie chart or a map. And this is the power of data visualization and how the science of products that allow you to see the data in the most effective way enable you to create the most valuable outputs. So there you go. I tried some circles and all sorts of other things. And after an hour, well, you just saw it a moment ago, I'd ended up with this. It's actually deaths over 40 years. It's capital punishment in the US, so executions in the US over 40 years. We do sometimes play with happy data. I realize a lot of my presentations, I'm like, oh God, it's all so depressing. But there are happy data sets too available. But the point was, I didn't know I was going to get to that. I didn't know that the data was similar to the Iraq's bloody toll view. I just went on this exploratory path and found a great way of communicating the output, as do 50 other people every week in the Makeover Monday project. And that's incredibly powerful. That's a community project, but that's incredibly powerful in your organization too. So I want to show you some of this in action. So I'm going to show you some data inspired by well, not really inspired by Star Trek, but if you think about Star Trek's mission to boldly go where no man has gone before. In 2016, we don't have warp drives, but we are pretty cool as human beings. We've got some pretty awesome technology out in orbit. One of the things up above us is this. This is the Kepler telescope, put into orbit, I think, 2010 by NASA. So this is a publicly funded telescope that is looking in a tiny patch of sky, and it's looking at stars in that tiny patch of sky where the light periodically dims. And astronomers, being awesome scientists, can take that light signature and work out if that dimming is caused by an exoplanet, a planet orbiting that star. Not only can they do that, what's amazing, just by the change of light, that's the only information they have, they can work out how far the planet is from the star, what temperature it is, and how big it is, which is incredible, right? 10 minutes to go. And the cool thing is, because it's NASA, anybody can download the data, which I happen to have in Tableau. Right, so I'm not an astronomer, but I'm going to do some astronomy to look for Goldilocks planets, okay? Planets that we could possibly go and live on if we had one shot to go and find a planet. So here's my data. I'm going to draw a blue square for every one of the exoplanets that Kepler's found. Now I do this, you wouldn't make a chart like this generally, but I'm doing it just to sort of get our visual cortex working. I've now added disposition on color, and what we can see is these orange ones. These are the confirmed exoplanets. The others are false positives or candidates. Turned out the data didn't come down to Earth as clean as they'd hoped. But what our brain is doing is quickly estimating and sort of seeing there's about 10 to 15% of the objects turns out they're planets. And then we can think, well, where is Kepler actually looking in space? And astronomers have this fantastic term, they call it right ascension. That's the 360 horizontal degrees, 360-degree horizontal view, and declination, which is sort of from floor to sky. And here's a little picture of where Kepler's looking at. So if I do this from 0 to 90 degrees, 0 to 360, what we have now is a 2D representation of the 3D sky above us. And cool, look, that tiny piece of space is where Kepler's found nearly 1,000 candidate planets. And if we zoom in on it, then we get another interesting aspect of the science of data visualization. Our brain loves to see groups and patterns, and there's a fairly obvious grouping and patterning going on here about where in space these objects are. And as a non-astronomer, I might have looked at this and thought, wow, what? Space is in a grid shape? That's amazing. That would be science, right? But it turns out that if you go and Google Kepler, I research, this is the imaging surface of Kepler. It's 25 really strong digital cameras in the array. Of course, that might mean right here might be the most Earth-like planet in the universe, and we'll never know. But anyway, so there we go. That's where they are in space, and you can go outside and look in that same direction if you so wished. But the next thing we might want to do is think, well, of those 1,000 candidates, which ones could we live on? Which ones are the Goldilocks? So instead of, this is a scatter plot with the aggregate of all objects, so I'll draw a circle for all of them. And now I'm using position and color to show things. So on the y-axis, this is radius. So this planet at the top has a planetary radius 3,791 times the size of Earth. Gravity would kill us. I saw the film Gravity, and that guy spent 10 years on the planet, or whatever happened. So I'm going to remove the big planets and filter down to just the ones that are about 1.75 times the size of the Earth, which we all know is kind of the maximum radius that we could live on. I had to look it up. And now this is a bit more cool. So on the x-axis, we've got orbit size. So the ones near the 0 are close to the star. And you can also see that they're kind of hot because they're close to the star, because I've put color, I've put temperature on the color shelf. So we need a temperature that is all right. And apparently the astronomers were at 275 Kelvin. Let's go to 279, which is pretty cold, but they kind of say that's a good Kelvin temperature for us to look at. Right, so here we go. I've got 9 circles on the screen. I'm not an astronomer. I'm sure you're surprised to know that. But I know how to drag and drop data around. Right? I can just play with data and see what happens. And I found these 9 objects, which are kind of about the right size, about the right temperature. And the astronomers, some of you may have seen last year, they actually produced a list of 8 planets which they thought were the most like Earth. And they called these the Goldilocks planets, which I've just put on the shape shelf. So the filled circles are the Goldilocks planets that the astronomers put proper science onto it to look at for good exoplanets. And the one that's the empty circle is the one that I've found which isn't in that set. But that's pretty good, right? You know, we have just taken data from a public science body, connected it to a visualization tool, explored it, and got some really valuable insight about a field, let's be honest, I know nothing about. And imagine if I was a domain expert in my data, then I would be flying through this and asking questions, undoing, redoing, and doing some incredible exploration. And all of this is informed by the simple science. And an x-axis uses position to put things horizontally. A y-axis does it vertically. Color and size do all these other things. And that is why visual analytics is so powerful. So Kepler is awesome. We can find which planets we should shoot for should we ever work out a warp drive. We don't need to see the video. And here's an artist representation that NASA made of those 9 planets. 8 planets. So what we've seen is, very briefly, how our eyes process data or process information using and preattentive features are what the science has told us are great ways to encode data. We looked at the kinds of data you have, and we discovered some goofy stuff about Star Trek. But essentially, position, color, size, shape can be mapped to the types of data in your database. And when that's done effectively, you can go not for data visualization, but for visual analytics. You can explore your data to find those accidental, serendipitous discoveries answering questions you didn't anticipate. And that's essentially the essence of what Tableau is trying to do to help people around the world see and understand their data. And I'll just finish with 3 of the core beliefs which we wrap into our products. The first is that it's not just about science at all. It's actually about creativity and flow and bringing together multidisciplines. Because, Pollock probably studied art, but he wasn't constrained by a paint-by-numbers outline. He let his paint go wherever it needed to go. And that's what we do when we explore the Kepler data. We're just bringing data onto the canvas and letting the science of data visualization draw things in the most appropriate way to get it into our brains the most efficiently, or in the most efficient way possible. The second aspect is this aspect that not only does it have to be driven by science, it has to be beautiful. We see the government is trying to cut back on A-level art and history courses for kids, and I think that's an absolute travesty because science is hugely important. But people want to create things that not only make them feel powerful, but they create an emotion in the audience. And that's another key aspect of taking the science of what we can produce in tools like Tableau, but creating things that have that visceral and emotional response in our end users. Because the other core belief is insights are useless if they don't drive change. We are sitting on these mountains of data, and we're trying to work out ways to communicate that to ourselves, to our stakeholders, to our customers, to the public, to the government, everybody. And that essentially is the most important core belief we have. Here we were looking at space and exoplanets, but each of those dots could equally be patients in a hospital or students in a university, or just widgets that you're making in your organization and trying to make them more efficient. You can touch that data and manipulate it directly to get the best out of it. And so I'll finish with this slide. All of this, the visual analytics is really not about saying, oh, I've got timeline data, I'll make a line chart. Right? Why? Why would you do that? It's about getting to the root cause of your problems. You may start with a bar chart, but that will show you a problem which you will want to ask, why is that data a problem? And then why, and why, and why again, until you get to the root cause of your problems and actually create insights which create change. And all of that is wrapped up in what we've now got a 30-year-old academic field of the beautiful science of data visualization. So with that, we're on stand outside. Come say hello, we can talk a little bit more about it. There is a Tableau user group at 5:30 tonight. So if you want to go and meet some Tableau users and hear from the real customers, not somebody in marketing like me, then go along to that. They'd love to see you. But otherwise, I'd like to thank you very much for your time and have a great couple of days. Thank you.